Okay, so now that we know how to create various volumetric effects in Corona Renderer, let's see how to make them render even faster and what special effects they offer. So here are some tips and tricks. Let's unhide some object that we can use to see our volumetrics. I will start interactive rendering, and let's unhide maybe this guy. He's really nice for volumetric stuff because you can see the inside of his head, so this is a good idea. Okay, so let's take a look at some tips and tricks and things to avoid. So first, if you create a volumetric material, so let's just grab maybe just quickly create something with opacity set to 0, and like we can already see, sometimes your material which you are planning to make volumetric may appear completely transparent or invisible. And this means that either your absorption color is set to pure white, because then you will not see anything even if you increase the absorption distance, because whenever any light will touch this object, it will be still completely white, so we will not see any volumetric effect whatsoever, and even if we change scattering color or some other parameters, you simply won't see anything. So the solution is to make sure that your absorption color is anything but white, so simply lowering its brightness should help. And another reason why this may be happening is that even with some colored absorption, so non-white absorption, you may have 0 set as the distance here, and with 0 we basically disable this absorption effect. So just make sure that this distance here is non-zero. So non-zero distance and non-white color. We can then tweak all the volumetric parameters. Okay, so this is how to avoid your materials being invisible, and now how to render them faster. So again, let's just create something very simple. So maybe let's give it some absorption color, some distance, and maybe let's even enable some scattering. So something like this should probably work. Okay, and we should see the difference in performance now. So the first thing which you should always use whenever possible, so unless you need ultimate realism and you want your subsurface scattering to be really very realistic, is the single bounce only option. So enabling it will make the object darker because there is only a single light bounce inside of this object, but it will make it render much faster. So we can just compare how quickly it renders now. It just takes a while to reach the first pass and start rendering, start the actual rendering. And with this single bounce only disabled, it is a little bit slower, and we have to wait more to see the first passes. Okay, so whenever possible, definitely use this option to speed up your rendering. The next things are related to render settings, and I am already using some optimized settings, so let me just go to render setup, and I will just quickly reset them to defaults. So just right clicking on the spinners resets everything, and right now I'm basically using all the defaults that Corona offers. And here are some tricks how to render your objects faster. So the first thing, which is useful but only in the case where you are rendering mainly your volumetric object or only your volumetric object, so the best case is like this, when you just isolate the specific object, is to decrease the GI versus AA balance. So if I lower it, you will notice that rendering is faster, but this comes at the cost of other places in your scene. So if you have some global illumination, like some interior or something like that, it will render slower with this reduced GI versus AA. So in cases of regular renders where you're rendering, let's say, interior or exterior, it is definitely best to use the defaults, so 16 here. But if you just want to speed up the preview of your object, or just speed up interactive rendering, you can lower this to get slightly faster feedback. Now, another render setting which can help us here is Light Samples Multiplier, and this will, increasing this will actually increase the quality of your subsurface scattering. Let me just disable the hidden lights because there is something glowing here inside. Okay, and the default value is 2 and it works fine in most cases, but if you want to really increase the quality of your volumetric effects and basically of the light which is passing through them, you can increase this, but be careful with that, not to make it too high, and I would advise something like 3 or 4, and you should probably see even in the interactive rendering that the quality is changing. So if we lower it, you will see that the subsurface scattering effect is more noisy, and then it slowly refines. And if we increase it to the default 2 or higher, like 4, you will see that it gets better quality faster. But again, like I said, it's best to just use the defaults and try those things only if you want to speed up the rendering of some specific area of your scene. In case of Light Samples Multiplier, that's the quality of the subsurface scattering or the volumetric effects, because what you see here in this material is mostly direct light. Okay, so let's just reset everything. Another thing which works for volume grids and for the CoronaVolume material with inside volume mapping is the step size. So let's hide our head and unhide the fireball. Okay, we are using some custom colors here, but it doesn't matter, it's fine. And if we scroll down to rendering, you will see this setting called step size and interpolation. So let's say that we want to make our rendering faster. What we can do is change interpolation to none. This will slightly lower the quality of our volume grid, but it will also render faster. The issue that comes with changing this interpolation method is that you will see something like squares at some point. If we zoom in here, we will probably at some point see those blocks or squares. It's something similar to pixels but three-dimensional, so like boxes. But it will render faster. You can also switch to linear. This is the default mode, which offers something like best speed to quality ratio, or you can increase this by changing increase the quality by changing the interpolation to quadratic. This is the best quality mode, but it renders slowest. So that's interpolation, and then there is step size, and step size is something like the overall quality of this volumetric grid effect, and you should keep it always as high as possible. So this is usually dependent on the size of your object or scene scale and your system units. So for example, in this case, we can check how big our object is. So let's try with utilities and measure it. Okay, it doesn't show us how big it is, so we can try to guess it. So here we know, for example, that this is 10 centimeters, which is a lot compared to this object. So if we increase the step size to 10, we will basically say that the smallest allowed detail is 10 centimeters, and you will see that suddenly our object becomes strangely transparent and it just looks incorrectly, and that it's pretty noisy. So we can then try lowering it and try to find the optimal highest value. So let's try with 5. You will see that it becomes less transparent, but still it doesn't look correct. So let's try with maybe 2. And now we should see that the quality is getting better and better, and at some point it will just slow down without much increase in the quality. So if I try with something like 1 or 0.5, you will see that it will just get slower and there will be almost no difference to the quality. So finding the right value here is a bit experimental, but you should be able to simply create some helper object like a box, or just imagine what is the smallest detail that we want to render here. Maybe it's just like this tiny cloud here that we need to see. So it should be something like 1 or 2 centimeters in this case. And then you can just try increasing this and see if you are getting some artifacts. Like for example, here we are getting this transparent center, and the typical artifact that is coming from too high step size is bending. So if you increase it too high, you will see those bands or stripes in your volume grid, and this means that this step size value is definitely too high. So again, interpolation, worst quality, highest quality, fastest, slowest, and step size should be set to as high value as possible without getting artifacts or some rendering problems in your object. Okay, so those were the things that you can try to get the best performance out of your rendering of different volumetric effects. And now let's try to create some extra examples of volumetric things. So the first thing would be when you are creating clouds or some sort of smoke, you may sometimes want to get this silver lining effect that you get or that you see in photography, for example, when photographing clouds. So for this we can unhide our smoke object here, and let's say this is a cloud. It actually looks pretty much like a cloud, so that's fine. And I will disable the other lights and only leave this one, and this will be simulating our sun. Of course, you could also create a Corona sun and add the sky and add a cloud, but let's just imagine that this is our sun and this is a cloud. And let's maybe create a new Corona material or CoronaVolumeMtl, because that's exactly the use case for the CoronaVolumeMtl. And let's quickly set up the properties. So let's set absorption to black, distance to something low to make it pretty thick or dense, and then let's make scattering bright, something really close to white but maybe not fully white to make it faster. And let's enable single bounce only because we basically want it to render faster. Okay, and we are getting those nice edges, but what we are after is this pronounced bright edge effect called silver lining. So to do it, we can increase the directionality. Like I mentioned before, this is the direction in which the light gets scattered inside of the volume. So if we set it to positive values, it will be scattered along the way, the light will be scattered along the way it is coming from. So let's try it, and when we do it, we should already see that we are getting this nice glow on the edges and it becomes more contrasty. And if I lower it or use a negative value, the lighting will become more uniform and the edges will be less pronounced. So again, with 0 it looks like this, so we are getting something like a pretty linear gradient from the edge towards the inside. And with positive values, so let's try with 0.5, we are getting more pronounced and brighter edges. If we go too high to something like 0.99, we will just stop. Basically, we will stop seeing this effect because the light will continue just penetrating the cloud instead of reflecting into the camera. So I would say for cases like this, where you want your edges to be very pronounced and visible, the positive value for directionality should be somewhere between 0.5 and 0.8. Okay, let's now take a look at one issue that you may face when creating volumetric objects. So I will hide my cloud and I will just create a simple sphere anywhere, let's say here. And let's make it pretty low poly. So I will set segments to, let's say, maybe 8, or maybe that's too little. So let's increase it to something like 16. Okay, that should be fine. And again, let's create a new material with some volumetric effects. We can actually already see this, so let's use our cloud material that we created before. And the problem here is that you can see this kind of faceting. So if we, for example, use standard Corona material, you will see that the sphere is pretty smooth and you cannot see the faceting. But with volumetric effects, you will see them, and that's probably unwanted. You probably don't want this visible in your renders, because it tells everyone that this is a 3D CGI object. And here are some ideas how to solve this. The first idea is to increase the absorption distance, because then the differences between those edges will be less visible, and basically you will be blurring the surface. So let's try with multiplying this. So set the distance to 10 centimeters, and you can see that as we increase it, this effect becomes less visible. It's still there, but it's not so obvious. And let's try with some very high value, or even higher, and at some point it should completely disappear or almost disappear, like we can see here. But of course this method changes the appearance of your object, and you probably don't want that. So let's revert back to some low value so that we can see the faceting. And to get rid of this once and for all, the best solution is to subdivide this object. Of course, again, this is not always possible, but if it's possible, you can just go to modifiers, apply turbo smooth or some other modifier, and just tessellate it a bit. And at some point, again, with one it probably won't be enough, and you will still see those squares, those faces here. But if you increase it to some specific value, just make it higher, the faceting will disappear, because the differences between the edges will be too low to show the differences in shading. Okay, so here is how to solve this faceting issue if you ever encounter it in your scenes. Okay, now another thing worth mentioning with volumetrics is that LightMix works perfectly fine with them. So let's just unhide anything, maybe this guy with broken head. Okay, and let's give him maybe this cloud material, because we will then nicely see how LightMix is affecting this. So okay, or maybe we can even make it lower. Something like this, and let's enable our lights that we have here, and we can just stop interactive rendering and set up LightMix. I'm using Corona toolbar. I have it docked like this, but don't be scared, it's just the regular Corona toolbar. You can just dock it like this, and yeah, let's press the setup interactive LightMix button, and I won't be changing any settings here. Let's just generate it. And once this is done, we can start rendering, or we can even start interactive rendering to make it faster. And then go to the LightMix tab in the VFB, and you can see that you can just control each light independently, and it will affect our volumetric material. So you can decide which lights you want to enable or disable. Of course, you can also change the intensities of those lights, and you can change their colors. So the point here is that you can just not worry about LightMix and Volumetrics. They are supported. Like other features of Corona, they just work together without any problems. Okay, now there are also some limitations for the volumetric materials, and one of them is with the caustics solver. So let's take a look at this. If we just quickly create something which casts caustics, so I will just add some kind of sphere here, move it up a little bit, let's maybe make it a little bit smoother. Yeah, and I will also disable the other light sources just to see the caustics better and to make it render faster. Yeah, so let's create a new material and let's make it glass. So just like this, disable diffuse, enable reflectivity, enable refractions, and now we will enable caustics. And as you probably know, we have a new caustic solver in Corona. You can find some tutorials about it and articles about it, but the quick version of caustics tutorial is that you go into performance tab and you just enable the caustics solver, and that's all. So once we do that, you will see that the caustics will be calculated using the new solver. It looks like for some reason it's not happening. Caustic solver, generate from environment. Okay, because this light has generate caustics disabled, so let's just make sure that it has this option enabled. By the way, it's enabled by default. So once we do it, it will generate caustics with the new solver, which is fast and accurate. But the limitation here is that if you create some volumetric effect, like fog or some cloud or smoke, like this. So we have our glass sphere, and then it's casting the caustics on this volumetric piece of cloud or smoke or whatever volumetric material it is. The caustics which are cast on this object will be calculated using the old solver. So the new solver is ignored here, and this means that the caustics will be there, they will still be there, but they will be definitely darker, and they will just render much slower. So you can see that if we observe the caustics which are cast onto this volumetric surface, they are just rendering slowly. And if I hide this volumetric object, they will be again using the new solver, which is faster and more accurate. Okay, so this is just a limitation to remember. Of course, we would love to fix this, to use the new caustic solver for volumetric effects, but this will take some time because it's quite complex. But hopefully we will have it really soon in Corona. Okay, and now a separate case which is related to the volumetrics and especially volumetric fog is God rays. So some people want to create God rays in their mostly exterior scenes, but that's also possible in interior scenes, and they are having some troubles. So here are some hints how to set it up correctly and how to make the God rays pronounced. So let's open a different scene for this, and it's called God rays, of course. And let's check this scene. So basically we have some kind of landscape and some trees scattered on this landscape, so it's a simple forest. Let's go into our camera and let's enable interactive rendering. And when we do this and start rendering, we should see some God rays. Of course they require some time to render because everything here is volumetric. We have a volumetric fog here, but if we wait a little bit, you will see those rays of light shining through the trees. Okay, so how to do it and what are the things to consider? First of all, people sometimes expect God rays to appear in places where they shouldn't appear in real life, or where they wouldn't appear in real life. So if you, for example, have your sun shining from the top, from above, you probably won't get God rays, or they won't be very visible. So that's not the best way to do it. The sun has to be really low above the horizon to see those light shafts, those God rays. One good way to find out if light is in the correct position is to just hide the sky. So we will only leave the sunlight and increase the size of your sun. And then we can even hide the trees to see where exactly our sun is placed. So let's just switch to local rotation and let's make it maybe even lower a little bit, like this, or maybe that's too much. So something like this should be fine. And now we are perfectly sure that our sun is low and it will generate some God rays or light shafts. Then we can revert our sun size to 1, which is the default value, and even on this landscape we can already see those nice God rays. And then let's just unhide our trees, and we should get really clear and pronounced God rays. Okay, another thing is that those shafts are mostly visible when the sun is facing the camera. So if I go to perspective view and rotate my camera a little bit, they will be still there, but they won't be so visible again. So everything here is calculated correctly and according to what would happen in real life. And if we set our camera angle like this, you will see those rays here, those rays of sunlight, but they will not be very visible and very clear. So let's make sure that our camera is just facing the sun and that the sunlight is shining into the lens, into the viewer, basically. Okay, and one last thing which will pronounce the God rays is the brightness of the environment lighting. So we have the sun and we have the sky here, and if I go to material editor and I increase the brightness of the skylight, so our environment here, let's try with something like 2 or 3, you will see that everything will become brighter, but the God rays will be less visible. So they will be more visible if there is a lot of contrast between the sunlight and the skylight. So let's just make sure that the skylight is darker and that the sun is brighter, and then we will definitely get visible God rays. Okay, and the last part, which I forgot, is how to get the volumetric fog and the God rays at all. So first you have to create a new CoronaVolumeMtl, because that's what we should use for the volumetric fog. And then you have to put it into render setup, scene, and global volume material. So I will just clear this and let's set it up from scratch. So volume material here into the global volume material slot. Let's just put it here, instance, of course. And then we can adjust the parameters of our volumetric fog just like we do with our regular volumetric materials. So like I suggested before, we can set absorption color to pure black just to make it very easy to control. We are not getting any volumetrics right now because distance of absorption is set to 0, so let's try increasing it with a very big volume where we are using this material, because right now it's enabled for the whole scene, for the whole environment. We will definitely have to increase this distance to see anything, otherwise we will just see black screen like this. And as we increase it, at some point we will just see the trees and the sky and other things. So this tells us that we have the right absorption value, and then we can make the scattering color brighter. So let's try with some pretty bright values close to white. And when we do that, we should just make sure that single bounce only option is enabled, like this. And here is our volumetric fog. For some reason we still cannot see the God rays, so let's see, maybe we have to lower the absorption, or maybe we have to increase it. Yeah, this should be probably better. And one thing which greatly affects the God rays is directionality here. So under scattering, if you set it to some of the positive values, so again we are telling the volumetric material to continue scattering the light along the way where it comes from. So if we set it to some positive value, we will see those lighting effects, those God rays. Okay, and here you can actually greatly see how increasing the directionality makes them visible. If we just use the value of 0, there are no God rays at all, and if we start increasing it, 0.5, you will start seeing them, and if we increase it even further to something like 0.8, they will be really very, very clear. Okay, so now let's return to our studio. So I will just open the studio scene. And there is just one more thing. I promised to explain what are the differences between the standard Corona material with volumetric scattering and the Corona volume material. So let's just compare those materials. I will just hide this because we don't need it. Yeah, so we are comparing Corona material and materials Corona volume material. So if we look at the volumetric scattering options, we will see that they are actually very similar. So we have absorption, color, scattering, and so on. And here we also have exactly the same settings. But obviously the Corona material, the standard one, features more options. So for example, you can add all those surface related effects to it, but you can also add, for example, displacement or bump, which is not possible in the Corona volume material. And another thing is that this Corona volume material features something called emission. So again, let's unhide something like this. Let's start interactive rendering. And this emission option, basically, if we make it volumetric, so let's give it some absorption and some scattering, this allows us to make it glowing, the volume of this object, because as you can see currently we don't have any kind of surface, so the volume will start emitting some light. And if we just disable all the lights in our scene, you will see that it's actually emitting some light and it's basically glowing. So you can use this to create some sort of radioactive glow, or even a ghost, basically. Then there is one more thing in the Corona volume material, and that's and you cannot find it in the standard Corona material, and that's this volume mapping. It features two modes. One is on surface, which is the default one, and another one is inside volume. So let's see what exactly they do. I will just enable my lights back, go to the material editor, and then let's make this a volumetric material, so something like this, where we can clearly see the volume. And now I can use textures, so I can use procedurals or bitmaps to control things like absorption or scattering. So let's try with the default 3ds Max noise. Okay, and let's use it as absorption. So some areas which are black will be completely solid, let's say, or opaque, and the areas which are white will be completely transparent. So let's just lower the size of this noise to make it visible. Maybe something like this should work, and let's try with different thresholds, so 0.6, 0.4. And now that's what I explained. So some areas of the noise which are white are transparent, and another ones are solid, are visible, because it is used for absorption. And right now we are using this volume mapping option set to on surface, and as you can see, we are getting this noise texture, but it is evaluated on the surface of this object. So it's just a flat effect applied to the surface. Okay, it's still simulating the scattering and absorption and all the other stuff that is happening for the volume, but the noise is something like a cutout on the surface. And now if we switch to inside volume, this noise will be actually evaluated on the inside, so it will be fully volumetric. And now when we switch to this mode, this object becomes something a little bit similar to the volume grid that we showed before, and this means that we even have the step size option, which decides about the rendering speed and quality ratio. So we can try increasing it, and then we will see that the quality is getting much worse. So that means that we have to lower it and find the optimal value which will not render too slow and which will look good enough. So probably something like 1 or 2 centimeters should be fine. And just to let you see what this effect does, let's try just slightly tweaking this noise, and then it should be really visible how it's affecting the this material, this object, how it's cutting the holes in the surface, but also in the volume. So if we, for example, rotate the camera here, you will see that this noise here, this noise pattern is completely volumetric. Okay, and if we switch back to the on surface mode for evaluating the texture, you will see that it's just an effect on the surface and we don't see the volumetric shape of this noise map. How this is useful? It's honestly, it's mostly something like an eye candy, just the side effect of enabling those volumetric options in the CoronaVolume material. But it could be used for things like sponge, probably something that has some sort of volumetric structure inside it, or for some various special effects like some sort of glow, if you for example set it as emission, and then the volumetric noise will be glowing inside. Okay, so that's all I prepared for today, and I hope that you enjoyed this tutorial and that volumetrics and SSS materials are hiding no secrets from you now. Remember that usually getting the desired effects requires some trial and error, and that experimenting is one of the most important steps in learning new things, such as volumetrics. Happy rendering, and check out the rest of our tutorials.